Okay, number 8 says, what is an equation for the parabola shown below, or shown to the left, as in my case? Okay, so a parabola is a curve that is the graphical representation of a quadratic equation. A quadratic equation is where the independent variable, or in this case x, is squared, and that's the highest exponent on the variable. Since that is the case, then the equations for answers B, C, and D would not work for the parabola because their exponents, the highest exponent, is 1, which means those three equations are linear and they would be graphed as lines. So our only two options are either A or E. So looking at the equation for A, y minus 1 equals x squared minus 2. Let's solve that equation for y, because if we get y by itself, then what we will be doing is putting this equation in standard form. So add 1. So y equals x squared minus 1. What this tells us, when an equation is in standard form, like this here, y equals ax squared plus bx plus c, the constant in the equation is the y-intercept. So this means that our y-intercept is negative 1, which is not true according to this graph. If the equation was y equals x squared minus 1, then this parabola would cross the y-axis right there at negative 1, and it doesn't. So it can't be A. So let's look at E. Now by process of elimination, the answer is E, but let's look at why E is the equation. So we have y plus 1 equals x plus 2 squared. So again, if we solve this equation for y, move the 1 over, we rewrite our equation as such. Okay, so what we've done now is we have put this equation into what's called vertex form. Like this, in which case you can look at it and tell exactly what the vertex is. The vertex of this equation, it's the opposite of h and then k. So the vertex of this equation would be negative 2, negative 1, which could possibly work for that vertex. So either by process of elimination or by solving this and putting it into vertex form, we can see that the answer to number 8 is E. Number 9. Which of the following equations represents a line that passes through the points 2, negative 1, and negative 4, 3? In order to do this, we first need to find the slope of the line between the 2 points. So remember that the formula for the slope is y2 minus y1 over x2 minus x1, the change in the y's over the change in the x's. Also remember, it doesn't matter which order you put the y's in on top. You can do 3 minus negative 1. If you do 3 minus negative 1 in the numerator, you have to start with this x in the denominator and do negative 4 minus 2. If you start with the other y's in the numerator, you have to start with the other x's in the denominator. So I'm going to do 3 minus negative 1. Remember, that minus is part of the formula, so it has to be there no matter what x is, over negative 4 minus 2. So that's 3 plus 1 over negative 6, which is negative 2/3. Okay, so that's the slope of the line. M equals negative 2/3. Now, I can use either one of these points in the formula y equals mx plus b to find out what b is, which would then be able to give me what the equation is, or I can use the point slope form as we did using both methods in the pretest. I'm going to use point slope, which says y minus y1 equals m times x minus x1. So, and I'm going to use this point right here. So y minus 3 equals negative 2/3 times x minus negative 4. That changes to plus. So negative 2/3 times x is negative 2/3 x. Negative 2/3 times 4 is negative 8/3. Now, I know that looks awfully ugly to you guys, but I can get rid of those 3's in the denominator if I'll go ahead and multiply the entire equation by 3. So 3 times y is 3y. 3 times negative 3 is negative 9. 3 times negative 2/3 x is negative 2x. And 3 times negative 8/3 is negative 8. Now, all 4 of those equations are in standard form, so I need to move my x's over here. I'm going to add 2x to both sides. So I have 2x plus 3y, and I'm going to move that negative 9 to the other side, so I'm going to add 9 equals 1. So 2x plus 3y equals 1, which is D. Number 10, 3/5 plus 1/3. Okay, so when you add fractions, you have to have like denominators. The easiest way to find the like denominator, or the denominator to use, is to multiply those two, because you know both of those numbers will go into that product. So my new denominator is going to be 15. 5 times 3 is 15. So I have to multiply 5 by 3 to get 15. So I'm going to multiply by 3. So that's 9/15. Then I can multiply that by 5, and that's 5/15. So when I add those together, I get 14/15, which is E. Number 11 is a constructed response, and you have this kind of picture. It's a heart with a dotted line across it, and it says, explain what a line of symmetry is. A line of symmetry is a line that divides an image or a figure into two congruent parts. Congruent means same shape, same size. Okay, so if a line of symmetry divides a figure into two congruent parts, same size, same shape, then this line is not a line of symmetry, because it's not a line of symmetry because the part of the figure above the line is not the same shape as the other part. Or as the part below the line. Remember that on the constructed response, it's way better to write too much than too little. Number 12 is another constructed response. It says Liam is making chocolate chip cookies. The recipe calls for 1 cup of sugar for every 3 cups of flour. Liam has only 2 cups of flour. Okay, there are a couple ways to do this. He needs 1 cup of sugar for 3 cups of flour. Okay, he has 2 cups of flour. So he has 2 out of the 3 cups of flour. He has 2/3 of the total flour. So he needs 2/3 of the total amount of sugar. And 2/3 of 1 cup is 2/3 cup. So you want to say Liam needs 2/3 cup sugar. Okay, to explain why my answer is correct is because 2 of the 3 cups represents 2/3 of the total amount necessary of flour. So he also, in order to maintain the the recipe's integrity, has to have 2/3 of the total amount of sugar, 2/3 of that 1 cup. Okay, number 13 says a student thinks that the sum of 4.3 and 8.4 is 12.7 because 4 plus 8 is 12 and 3 plus 4 equals 7. The student then adds 3.7 and 2.6 and gets 5.13 because 3 plus 2 equals 5 and 6 plus 7 equals 13. Identify the mistake in the student's procedure and explain why this procedure won't always work. Use proper mathematical terminology. Okay, so here's what the student did. She did 4.3 plus 8.4 and she got 12.7. She added 4 plus 8 and got 12. 3 plus 4 and got 7. Then she did 3.7 plus 2.6. And following her original logic, she did the same thing. She did 3 plus 2 equals 5. And 7 plus 6 equals 13. Okay, what she failed to remember is that these numbers, these digits represent place value. And that is 7/10 and 6/10, which is not 13/10. Okay, in order to add seven plus 6 is 13, but remember you have to carry the 1. That next 1 goes on to the next amount. 3 plus 2 is 5, plus that 1 is 6.3. A way to look at it from her mistake, this 13/10 right here, that 13/10 represents the same thing as carrying that 1. 13/10 is 10/10 plus 3/10. Here's the 3/10, and then the 10/10, which is 1, is right there. So if she would have broken this 13/10 down correctly, she still might have gotten the same answer.